Introduction. Hook. Imagine a computer so powerful that it can solve in seconds what today's fastest supercomputers would take thousands of years to calculate. This is not science fiction, it's the promise of quantum computing. In this two-part series, we will explore how quantum computing works, why it's such a revolutionary technology, and how it could completely reshape the future of humanity. This is part 1, where we'll cover the foundations, what quantum computing is, how it differs from classical computing, and the industries it is already transforming. Section 1. What is quantum computing? Traditional computers, the ones we use today, rely on bits, tiny switches that represent either a 0 or a 1. Every website, video, app, and game is made up of billions of these binary codes. But quantum computers are different. They use qubits, quantum bits. Thanks to the principles of quantum mechanics, qubits can exist as 0, 1, or both at the same time, a state called superposition. Even more interesting, qubits can be entangled, meaning the state of one qubit is directly linked to another, no matter how far apart they are. This strange behavior gives quantum computers an extraordinary ability. They can process a massive number of possibilities simultaneously. Section 2. Why quantum computers are different. To understand why this matters, let's compare. Classical computer. Think of it as a person reading a huge library of books one by one. Quantum computer. Imagine thousands of people reading different books in the library at the same time, then instantly sharing their knowledge. This parallel processing makes quantum computers exponentially faster at solving certain types of problems. Section 3. The current state of quantum computing. Right now, quantum computers are in the experimental stage. Companies like IBM, Google, Microsoft, and Intel, along with startups like Rigetti Computing and IonQ, are racing to build the first fully functional, large-scale quantum computer. In 2019, Google claimed quantum supremacy when its quantum computer performed a calculation in 200 seconds that would take a supercomputer 10,000 years. IBM has developed cloud-based quantum computers, allowing researchers worldwide to test quantum algorithms. Governments around the world, especially the US, China, and Europe, are investing billions into quantum research. While these machines are not yet ready for everyday use, the progress is accelerating rapidly. Section 4. Potential applications of quantum computing. Why are people so excited about this technology? Because quantum computing could revolutionize multiple industries, medicine and drug discovery. Quantum computers could simulate complex molecules to discover new medicines, something classical computers struggle with. This could lead to cures for diseases like cancer, Alzheimer's, and rare genetic disorders. Climate change and environment. Quantum computing could optimize energy use, design better solar panels, and model climate systems more accurately to fight global warming. Finance banks and investors could use quantum algorithms to analyze markets and manage risks in ways never before possible. Cybersecurity. Current encryption methods, which protect our online data, could be broken by quantum computers. But at the same time, new quantum encryption methods, like quantum key distribution, could make data more secure than ever. Artificial intelligence. Quantum computing could supercharge AI by processing massive data sets faster, making AI smarter and more efficient. Section 5. Challenges facing quantum computing. Of course, quantum computing is not without challenges. Fragility. Qubits are extremely delicate and can lose their state quickly, a problem known as decoherence. Error rates. Quantum systems make more mistakes than classical computers. Cost. Quantum machines need ultra-cold environments, close to absolute zero, which makes them expensive to build and maintain. Scalability. Building a small quantum computer is possible, but scaling it to millions of qubits is the real challenge. Scientists and engineers are working hard to overcome these obstacles. Section 6. The race for quantum. Supremacy. Just like the space race of the 20th century, we are now in a quantum race. Countries and corporations are competing to be the first to build powerful, practical quantum computers. United States. Heavy investment through DARPA, NASA, and tech giants. China. Building national quantum labs and leading in quantum communication research. Europe. Billions invested in the EU quantum flagship program, Whoever wins this race may control the future of technology, finance, and even national security. Section 7. Everyday impact of quantum computers. While today's quantum machines are limited, in the future, they could become part of our everyday lives. Personalized medicine tailored to your DNA. Ultra-secure internet communications. Faster logistics making supply chains smoother. Smart cities powered by quantum-optimized energy systems. Quantum computing might not just be about faster calculations, it could reshape society itself. Section 1. The timeline of quantum computing experts have different opinions on when large-scale, practical quantum computers will arrive. 2020's now. Companies like IBM, Google, and Rigetti are building small quantum processors, 5,500 qubits. Cloud-based quantum computers are available for researchers. Early applications in chemistry, logistics, and finance are being tested. 2030s. Scalable quantum computers may become reality with thousands or millions of qubits. Industries like pharmaceuticals, materials science, and energy could experience breakthroughs. Nations may begin adopting quantum-secure communication for military and government use. 2040s. Fully functional, universal quantum computers could solve problems beyond human imagination. Everyday consumers might access quantum-powered apps on their devices. Entire sectors may be rebuilt around quantum-first solutions. 2050s and beyond. Quantum computing could be as common as smartphones today. New fields of science could emerge, powered by simulations we can't even imagine right now. Humanity might enter a new technological era defined by quantum innovation. Section 2. Risks of quantum computing. As powerful as quantum technology is, it comes with serious risks. Cybersecurity threats. Quantum computers could break traditional encryption systems like RSA and AES. Banking, military communication, and personal data could all be at risk. Economic disruption. Industries that fail to adapt to quantum technologies could collapse. New monopolies may emerge, giving unprecedented power to a handful of corporations or governments. National security. Countries that lead in quantum tech could dominate geopolitics. Quantum espionage might become a new form of cyber warfare. Ethical concerns. Who owns quantum breakthroughs? How do we ensure fair access to such world-changing technology? Section 3. The global quantum race. Quantum computing is not just about science. It's also about power. United States. Tech giants like Google, Microsoft, and IBM are leading. The U.S. government has pledged billions in funding. China. Building national quantum labs and pushing ahead in quantum communications. In 2016, China launched the Mikius satellite, the world's first quantum communication satellite. Europe. The EU's quantum flagship program invests heavily in research and startups. Other nations, Canada, Japan, and Australia are also developing competitive quantum programs. This race could decide the balance of power in the 21st century. Section 4. Quantum computing and artificial intelligence. 1. Of the most exciting synergies is between AI and quantum computing. AI training. Quantum processors could train AI models exponentially faster than classical supercomputers. Big data. Quantum algorithms could handle massive datasets beyond human reach. Smarter predictions. From weather forecasting to financial markets, quantum AI could make unprecedented predictions. This combination may lead to what some call the intelligence explosion, a rapid leap in machine learning capabilities. Section 5. Every day. Life with quantum technology. Imagine how different daily life could look with quantum computing. Healthcare. Doctors prescribe treatments based on precise quantum simulations of your DNA. Travel. Airlines and shipping routes optimized by quantum logistics reduce costs and delays. Energy. Smart grids powered by quantum algorithms make renewable energy seamless. Entertainment. Realistic virtual worlds simulated by quantum processors become part of daily life. Education. Students use quantum-based AI tutors for personalized learning. Quantum computing won't just change industries, it will change how we live, work, and think. Section 6. Ethical dilemmas. With great power comes great responsibility. Quantum computing forces us to ask hard questions. Who controls it? Will it be governments, corporations, or humanity collectively? Equal access. Will quantum tech be available to all or only to the wealthy and powerful? Job displacement. How many traditional roles will vanish in a quantum-driven world? Existential risks. Could combining AI and quantum computing create uncontrollable systems? Just like nuclear technology, quantum computing could be both a savior and a threat. Section 7. How to prepare for a quantum future. Individuals, businesses, and nations must prepare now. Learn quantum basics. Professionals in tech, finance, and science should study quantum concepts. Quantum-safe cryptography. Companies must adopt encryption methods resistant to quantum attacks. Invest in research. Nations must support open innovation to avoid monopolies. Adaptability. Workers should focus on creativity, problem-solving, and emotional intelligence, skills that quantum machines can't replicate. Section 8. The future beyond quantum. Some scientists believe that quantum computing is just the beginning. It could open the door to entirely new technologies, such as quantum internet, ultra-secure instant global communications. Quantum sensors, devices that can see underground, predict earthquakes, or detect diseases early. Quantum biology, understanding life itself at the quantum level, leading to radical health breakthroughs. The possibilities are as endless as our imagination. Conclusion. Wrap-up. Quantum computing is not just another step in technological progress, it is a leap into a new era. It has the power to cure diseases, stop climate change, and unlock secrets of the universe. But it also carries risks that could destabilize economies, threaten security, and challenge our ethical values. The real question is not whether quantum computing will change the world, it's how we will choose to use it. Will it become a tool for equality and progress or a weapon of control and dominance? The answer depends on us, the choices we make today, and the vision we hold for tomorrow.